Okay, so the first problem says, if y sine cubed x is this, if y equals sine cubed x, then dy over dx equals. So dy over dx is the derivative of y. So I want you to take the derivative of both sides. So dy over dx equals, you have to do the chain rule. So bring 3 to the front, 3, and then 3, you subtract 1 from the exponent, sine squared x multiplied by the inside, which is sine. So the derivative of sine is cosine x. So answer number 1 would be E. Okay. Graph f is shown above for 0 to 4. What is the value of the antiderivative of 0 to 4 of f of x? Let's graph f of x. Okay. So for this one, whenever it shows this, it's asking for the area between the x-axis and the curve representing f of x. So it's asking for the area between 0 and 4. So it wants you to find the area under the curve, above the curve. And since this part of the curve is below the x-axis, this part's going to be negative. So if you were to divide this in sections, 2 times 1 is 2. 2 times 4 is 8, divided by 2 is 4, equals 6. So the area of this section is 6. And down here, 2 times 3 is 6. But it's going to be negative 6 since it's below the x-axis. So 6 minus 6 equals 0. So the area is 0, which is B. Using the substitution, u equals x squared minus 3. The antiderivative from 4 to negative 1. X squared minus 3 to the 5th dx equal to which of the following? So I want you to use substitution. So first we have to find du, which is the derivative, which would equal 2x dx. And we want to get x dx by itself, so we can replace the x up here and the dx up here with a du. To do that, we have to divide by 2 and equal x dx. So now we can take this and replace the x and the dx. And then take this and replace it with u. So we get antiderivative of u to the 5th du over 2. Or you can write it as 1/2 u to the 5th du. Now we have to find the new limits, the new that. So if x equals 4, then u is going to equal, you plug the 4 in, or whatever number in, for the x in the u equation. So the u is going to equal 16 minus 3 equals 3. So up here, there's 13. So up here is going to be 13. And then if x equals negative 1, u is going to equal negative 1 squared minus 3 equals 1 minus 3 equals negative 2. So your answer is C. Voila. If arc sine of x equals ln y, then dy over dx equals, this is the same as number 1. So this is the derivative of y. So once you take the derivative, and it wants you to get the rate of the derivative, this is the rate by itself. So the derivative of arc sine equals 1 over square root 1 minus x squared. And then the derivative of ln y equals 1 over y. So you get 1 over square root 1 minus x squared equals 1 over y times dy over dx. This is the rate of the derivative. So now, in order to get this by itself, you multiply y to both sides. So then you get dy over dx equals y over square root 1 minus x squared, which is a. Perfect. Apply b minus a times r of b. I guess you could say plus blah 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 and keep going. Okay, so 7 minus 4 is 3. So this is the distance between. So the amount of hours that it skips is 3 hours. 3 times the rate at 7, which is 6.2, plus skips 5 hours times the rate at 12, which is 5.9, plus skips 3 hours, which is the rate at and the rate at 15 is 5.6. So 5.6 equals 114.9 liters, which is C. All right, number 10 is asking for the antiderivative from the interval 1 to 4 of t to the negative 3/2 dt. So in order to find the antiderivative, it's the opposite of driving. The antiderivative is the opposite of driving. So instead of subtracting from the exponent, you would add 1 to the exponent, or 2 over 2 for this case, and then divide by what you add. So then you would get negative 3 over 2 plus 2 over 2 equals t to the negative 1/2 over 1. 2 over 2 is the same as 1. So it's t to the negative 1/2, which is the same as 1 over t to the 1/2 from 1 to 4. So 1 over 4 to the 1/2 minus 1 over 1 to the 1/2 equals square root of 4 is 2. Square root of 1 is 1. Negative 1/2. See. Alright, let f be defined by f of x equals square root absolute value x minus 2 for all of x, which of the following statements is true. So first we're going to see if it's continuous. So f of 2, so plug in 2 for x, so 2 minus 2 is 0, absolute value is 0 is 0, square root of 0 is 0. So it is continuous, so C cannot be the answer. And if it's continuous, then it's not a vertical asymptote, so E cannot be the answer. Let's see if the limit exists. So the limit of x approaching 2, square root x minus 2, absolute value, plug it in, equals 2 minus 2. So the limit equals 0. So this says the limit does not equal 0. So that's false. So now we see if it's differentiable. So to do that, you have to see if there is any corners or slopes. So since this is an absolute value graph, we know that it is not differentiable because the graph of the absolute value graph looks like this. And this is absolute value. So we already know that it's not differentiable. So that means that A is the right answer. Okay, so for this one, we have to do some out-of-the-box thinking. So the graph of a differentiable function f is shown above. If h of x equals this, which of the following is true? So the derivative h equals f of x. So this would be like the graph of the original function's slope. So this is the graph of the slope. So like if we're doing like position, velocity, acceleration, this would be the velocity graph. That's why I like to think of it. Okay, so which of the following is true? Looking at 6. Okay, so on the original graph, it said, okay, so on the original graph, okay, so on this graph, this again is equal to 8 to the derivative of h. So technically right here at the derivative of h, it is 0, or it is 0. So equals 0, right? But for the original graph, since it's had a constant negative slope up until this point, it's going to have to be negative because it's up until 6, it has been going down up until 6. So it's going to have to be negative. So that leaves us down to, this is negative. Okay, so then the h derivative is the slope of this graph. So at 6, the line is increasing. So that means that therefore this is positive. So therefore, this is 0, means that A is the correct answer. The graph of f derivative, the derivative function, consists of 2 line segments in a semicircle, as shown in the figure above. f2 equals 1. So at this point, this is the velocity, so this is the graph, the slope of the original. So at this point, the original position at f of 2 equals 1. So we want to find the position at f of 5, the original position, because we do not know it. In order to do that, we have to find that this area under this curve and the area under this curve to find the displacement between this point and this point. So in order to find this, you do base times height over 2, which equals 4. So the area under this triangle is 4. And the area of a circle equals pi r squared. Since this is a half circle, you divide it by 2. The radius is 2. So 4 pi over 2 equals 2 pi. So what we just did here is this equation, the antiderivative from -5 to 2 of f derivative of x, which is the same as f of 2 minus f negative 5. f of 2 equals 1. We already know that. So we're looking for f of negative 5, which equals this displacement. So 4 minus 2 pi, we can replace 4 minus 2 pi for this, because positive, what comes above the x-axis is positive, what's below the x-axis is negative, so therefore it's 4 minus 2 pi. So 1 minus f of negative 5 equals 4 minus 2 pi. Subtract over the 1, you get 3 minus 2 pi. Multiply over the negative 1, you get f negative 5 equals negative 3 plus 2, or 2 pi, or 2 pi minus 3, which is b. Function f is defined by f of x equals x over x plus 2. What point xy on the graph of f have the property that the line tangent to f at xy has a slope of 1/2. In order to find this, we have to solve for f of x, the derivative, to find the slope, and then replace f derivative of x with 1/2. So in order to do this, we have to do the chain rule. The chain rule is a little rhyme. It's low. Take what's on the bottom times the derivative of the high. Derivative of x is 1 minus the high, which is the one on top, times the derivative of the low, which is 1. Derivative of x plus 2 is 1 over low. So x plus 2 squared, because x plus 2 times x plus 2 is x plus 2 squared. If you simplify this, you get 2 over x plus 2 squared equals f derivative of x. But we want it to equal 1/2. So now, set equal to 1/2. So solve for x, multiply both sides by 2, multiply both sides by x plus 2 squared, so then you get 4 equals x plus 2 squared. So then you get x plus 2 equals plus or minus 2, because you take square root of both sides, you have to add plus or minus the square root, and square root of 4 is 2, so plus or minus 2. Then you subtract 2, so then you get, but you have to subtract 2 from the positive and subtract 2 from the negative 2. So 2 minus 2 is 0, and negative 2 minus 2 is negative 4. So then you get x equals 0 and negative 4. So you have 2 x answers. So then you plug the 0 back into the original equation, and you get 0. So one of your points is 0, 0. And then you plug the negative 4 back into the original equation, and then you get negative 4 over negative 4 plus 2. So then that is negative 4 over negative 2, which is just 2. So then your other equation is negative 4, 2, which means that your answer is C. The line y equals 5 is a horizontal asymptote to the graph which of the following functions. So in order to find this, you just set the limit. You basically define the limit going to infinity, approaching infinity for every single one of these answer choices. So for this one, as this gets bigger and bigger and bigger, as x gets bigger and bigger and bigger and bigger and bigger, technically since the sign is on top, it's going to get to an itty tiny bitty number and then divide it by our huge number, which can be 0. Because it's a little tiny number or a big number, which is going to be approaching 0. So as it goes to infinity, it's not going to stay at 5. So that's why that one's wrong. And for this one, if the x is like a million or infinity, it's not going to equal 5 because it's going to also be infinity because it's going to be multiplied by 5. So this one is also wrong. And then for this one, if the x is a million again, then 1 over a million is just 0 because it's so small that it's not even counted. So that's also not going to equal 5. And for this one, you can use your horizontal asymptote rules where you take the exponent of each of the variables and set them over each other. And if they're the same, then you set the coefficients over each other. So this one is going to equal negative 5, so it's still not the answer we're looking for. Use the same rule for this. 2 is the same as 2, so 20 over 4 is 5. So your answer is E. Let g be a continuous differentiable function where g of 1 equals 6, g derivative of 1 equals 3. What is the limit of x approaching 1 of the antiderivative from 1 to x of gt dt over gx minus 6? So this is asking for, so in order to find the limit, we're going to plug in 1 in for x. So we're going to get 1 to 1 gt dt over g of 1 minus 6. So this is asking for the displacement from 1 to 1 of g of t, or g of 1 g of x of 1. So that we'll just call this, because g of t is the same as g derivative of x. It just makes it easier. Plus derivative. So g of 1 minus g of 1. So it doesn't matter what g of 1 is. We know g of 1 is 6. So 6 minus 6 equals 0. So this is going to be 0 on top, divided by 6 minus 6, which is 0 over 0, which cannot work. So whenever you have 0 over 0, you can use a special rule where you take the derivative of the top and the bottom to see if you can get another answer other than 0 over 0. So when you have a variable as your interval, when you take the derivative of that, then these two switch places. So when you take the derivative of that, you just get g of x over g derivative of x minus 0, because the derivative of 6 is 0. So g of x, so then that would equal g of 1, since we're looking for the limit at 1, over g derivative of 1 equals g of 1 is 6, g derivative of 1 is 3, so it equals 2, so the answer is D.